All right, what we're looking at here is one of our practice problem questions, and I have the full thing set up. And I want to go over how we put this guy into graphing calculator and how we decide how to do our calculations and such. All right, so I'm going to do this full thing. So I've just got my TI going. I hit the y equals. And what I'm going to put in is this equation, pretty much how it looks. Now, it is going to be all in one line. And what I mean by one line, when I put this bottom in, I'm going to make it look like I'm just multiplying it by it. And how I'm going to make it to the right exponent is I'm going to raise that to the -2, because that actually is the inverse essentially. And then subtract our y, or our k from it. So we have everything on one side of the equation. So everything's equal to 0 this way. And on this, when I hit graph, I don't see anything terribly interesting because it's not necessarily making me a good graph. All right, now what we've been doing is calculating a 0, giving an initial guess. Now, how we come about these guesses, this leftmost guess is always going to be an x equal to 0. And where that came from, a 0 would mean the reaction's not changing at all. So it must start at 0. All right, so I'm going to hit left bound is 0. And there's a couple ways to get the right bound. Now, the easiest way, or the most logical one, is to look at these two terms that are negative, that have the minus x, because that's what's going on is as the x increases, these values, the reactants gets, or the products in this case, get smaller and smaller. Well, they can't go to 0 because, or they can't go beyond 0. They can get to 0, like we could lose all 0.4 grams of, or moles of the whatever B is, but it couldn't go to 0.5 because that would give us a negative value. So the largest this could be is 0.4. The largest this one could be is 0.6. So it'd be fine to put in as a right bound the 0.4. But what we can do is if I hit this arrow key, see how that popped up a value for the y? If I just keep going over, see how that just changed signs? It went from, it was positive and then it went negative. The only way that happened is this polygon, or a polynomial that we've graphed, has actually crossed the 0 mark. So we could use that, just that idea alone, just actually, it started out positive, it went negative. We know it crossed that axis, and I could put that as my right bound. So I don't actually have to put the 0.4. I really could just go until I don't see anymore. And then what I'm going to do is back up here on the guess and just put 0 in. And right like that, it got us an actual x of 0.339. But we let the calculator do it. We could always calculate our r, or our range. In this case, we'd probably use that number because it's the smaller of the two, and put in the numbers for a guess. But as long as you're watching what's going over here, hitting that a couple of times, you'll see that value change. And it's like, in this case, it went from positive to negative. It might go from negative to positive. You're just looking for the sign to change. And as long as you see a sign change, you went far enough out that you went beyond the where the value changes. But the 0 is the important one. The bigger one, we just need to actually remember we can't go too large, because if you go too large, these things become negative. And we can't have that.